This the foundation stone was laid down by our visionary leadership Pandit Jawaharlal Nehru in 1947. See, basically, role of NPL is well before at the time of independence. If you can remember that in the earlier last century, it was totally it was not there with us. We were the slave country, and all the industrialization went on in the Western world, and we were left far behind in the industrialization. So at that time, there's visionary leadership, because you can have the trade when you have your own measurement system. See, if you think that how the dimension this base units have arrived, this if you say the same say, 7 base units, food has, very interesting to know that food has originated from where. Basically, it's the average of the some king or some 7 people average out, and it was circulated around the world in the Europe, and then from there it went to the Asia. So standardization is a very important part. So that way it moved on. So unless and until you have a precision measurement system, you cannot move any industrialization of the country. So this is what 1875, how the world thought that we need to have, when we need to have the global trade, you need to have the same measurement system. 1875, this treaty was signed by the few countries, and then it has 2 parts, one the diplomatic and the scientific. So this is basically the government level CGPM, General Conference on the Weights and Measure, and then this is usually signed by the government of the country, any country, means senior officials, and then here it comes the national this specialized international body, and the national here it comes the National Metrology Institute, NPLI, National Physical Laboratory of India, and then they keep on whatever the new development going on around the world. So this moves on, any changes on the SI unit measurement system, it takes care of this part. So like this the NPL India, see, we do have the artifacts of the 1 kilogram weight. Every 4 years we have to take it to the BIPM France, and then again standard deviation, all weights around the world, they go there and take out the error, how much it has gained or have lost the weight. So then it's circulated around the world again. Next one. So this is the BIPM, where the first meeting in 1875 was. Yeah, next. So these are the base units, 7 base units. You can see here SI base unit, and few are the derived unit. You say the volume, area, and velocity, and rest of the units are all derived unit. It generated, but these base units have to be played, and they are the primary standards. The NPL maintains those primary standards, and we always remain at par with the international level. Next one. So this whole world is divided. All measurement institute cannot be, then one general assembly cannot be at one place. Then it has divided in 6 parts. So we fall into this blue portion of this one. You can see that this is Asia Pacific on materials metrology program. So we part of it. Last year in December we had this meeting, and all these countries met together and decided how we can collaborate, how we can enhance the measurement capability of each other countries. Next one. So this is the one BIPM France building, which I have shown you there, and then we are one of them. We are one of them, regional metrology organization, and then this is the part of it that suppose if you want to have the measurement capabilities, we develop certain things, and then we send our sample to there, and then they do the intercomparison and come out with some uncertainty in the sample. Next one. So this is what altogether in a CSR NPL, if you look at it, BIPM and this RMOs, and then here CSR NPL has 239 measurement capabilities, and developed countries they have 1,000, 2,000. But unfortunately, because the time and again so many things happens, so it's important part is the more the measurement capabilities you have, more you are accepted in the world. Okay, so whatever you say the data, then it's accepted anywhere. So as on today, see many times what happens, then Americans, last month I had a friend from America, but he was hesitant to drink the potable water, distillery he was not. They bring the water even. They bring some kind of a sample along with them which they put on to it. Reason is because they don't trust us. Our measurement capabilities are not there. So we have to come strong. We have to improve ourselves in this direction. This is the base unit as on current system 2018. These are the three. You see the kilogram. Kilogram is the artifacts, and second and meter, and rest on the physical constant. Now the new system is going to arise next year onwards. 2019 the convention will take place, and BIPM perhaps only second will be the only base unit from the coming year, when the convention, our director and National Physical Laboratory will take part on that. Rest of the units will be derived from the second. Now I come to the nanotechnology for which we have been sitting here. This is the basic background. So we look at it here. When you go to the finite size of the material, then you see that lots of changes are coming on this. What is happening there in the system? So what we see that when you keep on compressing to something, surface to volume ratio becomes very large, and then the pressure builds up on this one, and you find that then the structure, every material is, everything is made up of the atoms, then atoms are compressed over there, and then what we say that then the defects are created in the system. When they created, then the defects are created, then the structural changes takes place. When the structural changes takes place, they are all physical, chemical, all properties, they change. This you can see the example here. Gold nanoparticle 25 nanometer in different color, and they are insulator, and then 50 nanometer they come in the this thing, different color, 100 nanometer again, what we see the gold there. So what is happening there around there in the system? What is happening that the band gap is increasing. The layer, when the atoms come closer, finite, the layer becomes, then it becomes something like this, particular light is passing through this one. So that way we find the changes. Similarly, we see the silver nanoparticle there again. Different shape, different color. Almost near to 100 nanometer silver particle, 100 nanometer this thing. So these are the phenomena which occur there. And now nanotechnology means we are coming very close, very closer to the nature. How the nature does it. Simply you can have the example of the photosynthesis. How the plant takes this light, then radicals, then this breaking the molecules, and then finally this process goes on. So now when how close we can have on to this one, this is the main concept of the nanotechnology. These are some of the example I have said that photographic paper, filter nanofibers, and then food packaging. Last time when we had gone to some of this our standard document development, then this Iranian group, they are coming for the food packaging, some food packaging, this international standards, ISO document, soon it is going to come there. Okay, fungal, antibacterials again, this is in US now, almost all clothes are coming as antibacterial clothes. Antibacterial clothes, what did they do? The particle size is so fine, it penetrates to the bacteria and makes it ineffective. This is the main reason, the silver nanoparticles. So almost all the clothes in America are antibacterial, and this our new document, this Korean group is developing this ISO document. Yeah. So there are so many applications. You can see the down one chip there. There is the total chip size is the micron. I think if you look at it, scale here, this is I think 2 to some micron here, some micron. It covers entire things over there, entire complete device. Nowadays hearing aid is small, I think 2 millimeter in size. What is happening there? You are taking the all nanomaterials in the sense, we take the liquid suspension of the nanomagnetic particles. It works as a wonderful damper inside. It damps the noise, because when the transducer and this, it sits under there, and it works as a wonderful damper there. So it suppresses all metallic sound which is coming from your device. You get the pure voice, you get that one. So this is what the nanotechnology has a tremendous role to play, and India has to take lead on this one. How we do it? We develop by the document, we do that in the lab, genuinely, and instead of publishing a paper, we come to the devices.